Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And welcome back to basic physics course. And this material is for international student of UMS Mechanical Engineering Department. And in this video, we are going to learn a new topic. Yeah. And let me share the screen first. Yeah. Okay. And I think this video will be divided into 2 or 3 parts, yeah, because if I have to make it into only a single video, then this course will be very long. So I think I will divide this topic into 2 videos, yeah. Okay, and there are about 16 pages, yeah, of this topic, but I will try to give you the most important part of this topic. Yeah, so I will give you the highlight, yeah, of this topic. But if you want to know more or deeper understanding about this topic, you can just do it by yourself, yeah. Okay, now we are going to learn about this one. So let's let's start from the title of the topic itself. We are going to learn about motion. So this is the motion, and the additional information of the motion is the straight line. Yeah. In our daily life, yeah, motion can be various. Yeah, there are a lot of types, yeah, of motion. Yeah, there is stripe motion, yeah, and then curve, yeah, or wavy, yeah. So a lot of types, yeah, of motion. And in this topic, we are going to learn, yeah, the simplest types of motion, which is a motion along a straight line. Yeah. So this is the key point of our topic in this recording. Yeah. Okay. And okay, I think can go to the next page. Okay, so this is the concept. There are terms that we need to understand first. Yeah. So we have displacement. Yeah. We have type, and also we have average velocity. Yeah. I think for time, we already know, yeah, about the time. So 1 second, 2 second, 3 hours, yeah, that's kind of time. Yeah, the the physical quantity, yeah, of time. I think everyone has already known about this. And also the displacement, yeah. In our previous meeting, yeah, there are 2 types of length, yeah. I don't know how to say this one, yeah, but if we make some kind of table, yeah, and then I will put this one as scalar, and then this one is vector, yeah. Then the scalar is distance, yeah, and then the vector types of the distance is displacement, yeah. So like what we have learned, yeah, on our previous meeting, yeah. And then because the displacement is vector, so the direction must be considered, yeah. For the distance, it's only value, yeah, the value of the distance between point A and point B, yeah. But the displacements, it's not only value, yeah, but also we have to take consider of the direction. Yeah, so we have value here, and also direction. Yeah, so it can be positive or minus. Okay, that's the displacement. And then for the velocity, yeah, so if I make another table here, so this is scalar and this is vector. So this one will be speed, yeah, and this one will be velocity, yeah. Okay, the unit of speed is the international unit, yeah. The international unit is meter per second, and also for the velocity is also meter per second. So in the term of unit, yeah, these two quantity have similar units, yeah. But if we define this based on the definition of scalar or vector, then the speed only has a value, yeah. And for the velocity, due to because of vector characteristic, so it does not only have value but also direction. Yeah. And the symbol of velocity is v, a small v, yeah. And we have to differentiate between the bigger v, yeah. The bigger v means volume, but the small v, the smaller one, yeah, defines velocity. For the volume, it is meter cube, and for the velocity, it is meter per second. Yeah. Okay. And also there is a word in bold form. Yeah, there is a bold word, and it says about particle. So in this case, yeah, when we are analyzing a motion of certain things, then we can make it. We can simplify, yeah, the system into only a particle. Yeah, in our first meeting, yeah, this concept called with idealized model. Yeah, so this one is idealized model. Yeah. So we take the simple form, yeah, of a system when we try to analyze the physics of the things. Yeah, so we can use the idealized model. Yeah. Okay. And then wait a minute, I have something to do. Okay, sorry. Okay, let's continue. Okay, so about the particle, yeah. And then we are going to talk about the average velocity, yeah. Okay, so I will make it a simple thing. Nah, let's say it is point A, and it is point P. Yeah, and there is a path here, yeah, or a road or whatever you can say, but this is the straight road, yeah, or a straight path, and then I have car here, so this is the car. Yeah. And the displacement, I mean the length, yeah, between, I mean the distance between A and B, but in this case actually displacement, yeah. The A and B, yeah, are separated at, let's say, 100 meter, yeah, from A to B, yeah. And then the car move from A to B, yeah, so from A to B. And the time that needed by the car, yeah, the time that needed by the car is, let's say, 10 seconds, yeah, from A to B. Yeah. So in this case, we can find the value of, yeah, from this situation, because we have um, the the displacement, yeah, and also we have the time. We can find find the average velocity. So the average velocity is the velocity of the car, yeah, that moves from point A to point B. Yeah, the term of average can be in this topic, yeah, in this term, yeah, because in real life, yeah, the velocity of car at any point can be various. It can be different for every point. Yeah, let's say I will make this is, let's say, point 1, and then point 2, point 3, point 4, point 5, and point 6. Yeah, if we measure the velocity of the car in every point, yeah, it can be various. Yeah, it can be different for every point. Let's say when the car is at point A, the average is the velocity is high, and then at the point 2, the velocity is lower. Yeah, and then the car increase the velocity, so the velocity will be higher in point 3, but the car will decrease the velocity at point 4. So at the point 4, the velocity is lower. So in our daily life, in the real life, yeah, the velocity of particles, or in this case car, yeah, can be different, yeah, in any point. So the average mean we try, yeah, to find the average value of velocity, yeah, from point A to point B, yeah, without considering the velocity at point 1, 2, 3, 4, 5, 6, and etc. Yeah, so this is called the average velocity. Yeah, and this is the how to say, the example. Yeah, the example. So this is the truckster, yeah, or car, yeah, car that used for race, yeah, and the car moves, yeah, from point P1 to point P2, yeah, and this is the start line, yeah, and the start line is used as a reference point, yeah. So this is the reference point, yeah. Reference reference point in this case, in this point, yeah, it's a reference point, yeah, which is uh, 0. Yeah, the reference point is like when we have Cartesian coordinate. Yeah, the horizontal line is x and the vertical line is y, and the reference point is in this point. Yeah, so it's 0.0. But in this case, because the road is only in horizontal form, yeah, so the reference point is only 0. Yeah, so this is the 0 it here. Yeah, and the car moves from point P1 to point P2, and the point P1, yeah, is 19 meters, yeah, at the right side of reference point. Yeah, so this is the reference point, and the displacement between 0 to P1 is 19, yeah, which is the x1. Yeah, so this is the x1. So the x1 is 19 meters. The value of 19 meters can be measured from reference point to the P1. Yeah, so the x1 is 19 meters. Yeah, and then the car moves to the second location or the second point, yeah, which is P2. Yeah, and the displacement, yeah, between P2 and the reference point or the start line is 277 meters. Yeah, so this is the x2. Yeah, or the last point. Yeah, so this is the initial point, and then this is the last point, P2. Yeah, how to, okay, this is last point. Okay, and then the time that spent the time spent by the car that moves from point P1 to point P2 is 4 seconds. Yeah, so this is the not 4 seconds, but when the car moves at point P1, yeah, the time is recorded at 1 second. Yeah, so the car start from the start line. Yeah, the car from the start line, and at the time, yeah, the t or the time is recorded as 0 second. Yeah, because the car is at I mean the car is on start line. Yeah, but after that the car moves, and when the car location is at point P1, the time is recorded at 1 second. Yeah, so I hope you can imagine. Yeah, imagine what's going on inside this example. Yeah. So at this point, it's still 0 second, but when the car moves and reach the point P1, the time is 1 second. Yeah, which is the T1 in this case. Yeah, the T1 or the initial time. Yeah, so this is the initial time. And then when the car moves and reach point P2, yeah, the recorded time shows 4 seconds. Yeah, so this initial, not initial, but last, yeah, last time. Yeah, or some people say it with final time. Yeah. Okay. Now let's conclude here. What data that we have obtained from this example? The first one is initial point. Yeah. Initial point, which is P1, and P1 is also known as X1 in this case. Yeah, in this example, yeah, X1, and it is 19 meter. Yeah. And then last point, which is P2, or x2, it is 277 meter. And then for the initial time, which is t1, it is 1 second. And then for the last time, or t2, it is 4 square. And the formula to find average velocity is this. So this is the average for the formula to find the average velocity. So I will make it clear. So v average x. V means velocity, average means the average, and x means the average velocity in the x coordinate. Because as you can see on the screen, the cars moves on the horizontal line. So it can be, so we can also use, we can define this. The line is like the x-axis. So that's why the symbol use x. And then equals delta x divided by delta t. Delta x is final displacement, or final point, not final displacement, final point minus final or last point, minus initial divided by final time minus initial time, or we can make it simpler. So this is not very mathematical. So we have to make it into mathematical symbol. So the final point is x2, and then the initial point is x1 divided by t2 minus t1. So this is the formula, of average velocity. So x2 minus x1 is 258 meters, and then for the time, for the delta time or difference time, from point P to from point P1 to point P2, 4 minus 1, so it's 3. So 258 divided by 3, and the answer is this number. And actually you can check it with your calculator, because I think I think it's correct. This number is correct. So the average value of the car from point P1 to point P2 is 86 meter per second. Okay, so this is the concept of average velocity. Okay, next we have another. Okay, you can just read this by yourself, because it's still the same. But in this case, the car moves from right to left. So we have minus here, because the car moves into the negative x direction. So That's why the velocity really takes consider of the direction, yeah, because it's a vector, yeah. Okay, next. Okay, after this, yeah, on the next video, we are going to talk about the instantaneous velocity, yeah. And I think I have to end this video first, and after that, you can just continue on the next video, yeah. Okay.